My name is Eric Michaud. I'm an undergraduate senior at UC Berkeley. I'm a math major, but I'm really interested also in physics and computer science. And I think that one of the most interesting questions, unanswered questions left in science is, are we alone in the universe? I think it's an inspiring question, and it's why I applied as a freshman to work with the Berkeley SETI Research Center. And I was lucky enough to work as an intern, a summer intern in 2018, and have been working with them since. Over the last several decades, there have been a number of proposals for doing astronomy from the moon. That is, of placing some sort of telescope on the moon. Some advantages of this include the fact that the moon has basically no atmosphere, it's above the Earth's ionosphere, and it can provide a stable surface for the construction of a telescope, for instance, into the contours of a lunar crater. Now, one thing that I was curious about was whether there might be any additional advantages for SETI of doing observations from the moon. And it turns out that there would be a number of them, but probably the most interesting one has to do with radio frequency interference, or RFI. Some important context here is that SETI astronomers look for electromagnetic radiation produced by technology called technosignatures. Now, the problem is that there's an abundance of human technology on the Earth and around the Earth as satellites, which produce signals which show up in our observations. And the challenge here is that when radio interference from human technology shows up in SETI observations, it becomes more challenging to attribute any individual signal to extraterrestrial intelligence as opposed to just terrestrial intelligence. Now, if you were to construct a telescope or place one on the far side of the moon, then, because the moon is tidally locked, it would always face away from the Earth. And also, it would always have the body of the moon underneath it, shielding it from interference coming from the Earth. The moon's ability to shield against radio interference from the Earth has been established both by computer simulations of radio wave diffraction around the moon and by direct measurements made by NASA's Radio Astronomy Explorer, or RAEB mission in the 1970s. Another advantage of doing observations from the moon is that the moon is, above the Earth's ionosphere, which normally blocks out low-frequency radio waves from reaching telescopes on the surface. And so a telescope on the moon would have access to whole swaths of the spectrum which have been previously unexplored by SETI astronomers. I think this idea of doing SETI from the moon is going to become more and more attractive over time, in part because launching satellites into space, into low Earth orbit, is cheaper than ever. And so organizations, SpaceX and governments plan to put tens of thousands of new satellites into low Earth orbit. And this is going to only make worse the problem of radio frequency interference for telescopes on the Earth's surface. And so I think that over the next decades, we should be looking to send telescopes into space, and one of the very best places to place such a telescope would be the moon. So we've submitted a short white paper on this to the National Academy of Sciences Decadal Survey on Planetary Science and Astrobiology, and we hope that this will stimulate discussion in the community, in both SETI and astronomy more broadly, about the possibilities for doing astronomy from the moon.